A very warm welcome to all the students who are joining us for this cybersecurity series. So the skills that we are going to and the techniques that we are going to explore in the duration of this course is going to be common for the following topics: ethical hacking, offensive security, red team engineering, and penetration testing. Now, what do these terms mean? Is something that we are going to look at ahead in this course. So, information security as a domain is pretty huge. That's what I've tried to represent in this slide. The orange colored rectangle here is if that's representing information security. Again, the diagram is not to scale, but just to give you an idea. So, considering information security being the parent domain here, it's a vast domain. So, cyber security is but a part of it. It's a small part of it. And this course that we are just begun here is a small part of cyber security. So, this gives you a kind of overview of what we are trying to study here. So, what is information security? Before we answer that question, we'll have to understand what it means by intellectual property of an organization. Now, let's consider that there's a private or government organization, doesn't matter. So let's assume a electronic equipment manufacturer in the defense sector. Now, a company like this would have spent quite a lot of time, many years of effort to develop their product portfolio, each product having its own architecture diagrams or design diagrams, the plans, the descriptions, patents and whatnot. So, all of this in a way is the result, the fruit of a lot of effort and time and money and energy that has been spent by this organization. So, ultimately resulting in what are business secrets and confidential stuff. So, this has to be protected at all costs, and so that's where information security comes in. Now, information security as a subject has many aspects to it, but the most important part of it is actually how to protect the intellectual property of an organization. That's what information security is all about. Starting with these familiar biometric access systems that are based on fingerprint or face recognition. Then you have organizations that talk about the number of security guards that they have appointed. They've got like security guards on every floor, including the underground parking, and where not, and guards protecting critical infrastructure inside their offices. For example, even these like kind of data storage or data centers, places where they have servers and so on. So that's the aspect of security guards. Then coming down to the more familiar and the big brother kind of thing, that is CCTV cameras. So organizations talk about, okay, we have got CCTV cameras all over the place, nothing can move without us knowing about it. And then you have the organizational level policies. Like no usage of pen drives or thumb drives within the office on any of the desktop computers or laptops that are that belong to the office. So you might have the administrator who actually enforces this policy by disabling that in in the configuration of the office desktops or laptops in such a way that when you connect these devices, they are not even recognized. So it's enforced at that kind of level. So similarly, then as we look here, you might have the so-called data centers, the server area under lock and key, where two people have to operate this at the same time for this thing to open and to gain access and so on. High tech stuff like this. And finally, we look at all this fire safety and fire safety equipment that a lot of people are must be familiar with. So the the fire safety equipment naturally takes care of if there's a fire emergency, or if there's some kind of emergency situation in the office, and there's a disaster, and that has to be prevented, and so on. So all of these aspects are part of information security, and let's look at some more aspects in the next slide. And we here look at some more organizational policies. For example, frequent backups. So let's assume you have a software development company, or companies that have their blueprints or architecture designs or design plans and software, I mean electronic format. So companies like these would definitely want to have frequent backups, something like once in a month, or once in a week, or once in a day, or even once in an hour. So this is the kind of policy that is usually implemented. Then coming down to audit, companies can have, okay, we have this internal audit in our organization every 6 months, and we have an external audit every year, and so on. So where they audit their processes and then say that we have improved these aspects based on our previous audits, and so on. And similarly, if you look at companies that work in software, or have a lot of software components, things like that, or as I mentioned, blueprints and soft copies of blueprints and so on. So they typically have either online cloud-based repositories, or their own server infra into which they commit their code regularly. Similarly, look at redundant resources, like a redundant internet connection, for example. So you can have a company that has more than one optic fiber internet connection, so just in case one goes down, the other can be used right away. You might ask, then what happens if both the connections go down at the same time? Well, they can then have some kind of wireless mobile based or satellite based internet connection. That's also possible. Similarly, then we have the concept of redundant storage. There's this thing called RAID 0 or RAID 1, this kind of configuration where you have there's a master hard disk or SSD, and then there's a bunch of these slave SSDs into which content is written simultaneously. So if there's a write in the master hard disk, then the same content is replicated across in the other slave hard drives, and so on. Similarly, you can think of redundant servers as well, wherein there's a primary server, and then if that goes down for some reason, then there's a backup server which immediately takes over, and so on. And of course, we can always talk about organizational policies that talk about password strength and rotation of passwords, wherein they say, okay, look, if you try to log in and your password is expired, then naturally you'll have to create a new password, only then you can log in, and so on. This kind of organizational policy that we are very familiar with. So all of these are more aspects of information security, but more or less in terms of policies. Now let's try to understand what is computer security. Now you do remember the diagram which I have shown before. Information security, the orange rectangle, this huge rectangle, huge domain, in which then we have cyber security, which is one small part of that. So that cyber security is exactly what is computer security. So cyber security is just a fancy term to say computer security, and that actually addresses a lot of things. For example, the servers that we are looking at here, rack mounted servers, or blade servers, or whatever, that belong to an organization. Then these laptops and desktops that we are familiar with, then smartphones like Android or iPhone, and iPads and Android tablets, and webcams, and similarly IoT devices which are used frequently. And then you have cloud-based storage, or computing resources, residential routers, or the bigger monster routers, the ones that kind of are made by Cisco, and so on. The industrial grade routers is what I mean to say. So all of these devices come into the gambit of computer security. So what that means is that from an organization security perspective, if any of these devices, either at the hardware level or software level, were to get compromised, were to be compromised, then that would result in a huge loss for the organization. So that's the whole point of cybersecurity. That's the whole idea of cybersecurity. So which includes operating system security, hardware and software firewalls, intrusion detection systems, antivirus, malware scanners, and software specific features wherein if administrator logs in, then he's got a certain set of higher level privileges compared to when a normal user logs in who's a non-admin, having lower level or a normal user level features, that kind of thing. Then you have authentication, wherein different examples like biometric access. So you have your fingerprint, which is used to log into your computer, or strong passwords and so on. And of course, then you have the concept of authorization, wherein the privileges that a user has will clearly depend on what level of login he or she has. I mean, you log in as administrator, you get higher privileges, you are authorized to do certain things, and then if you are not an administrator, then you have lower level privileges and you can't do certain things and so on. So that's the idea. Now you can look at cybersecurity broadly at two levels: the hardware layer and the software layer, which is the higher layer above the hardware. Now again, the software, for convenience of explanation here, I have split it into three layers, further layers. So they are the device drivers. Sorry, just a moment. So what I'm trying to tell here, what I'm trying to say here is that if the if a hacker or a threat actor manages to break into an organization's hundreds of devices, any one of those devices, for example, and compromises the hardware or the software, again the software as in the the device drivers or the operating system or the applications, then there is a serious threat to the organization's intellectual property, and the hacker may cause a lot of damage ultimately. So therefore, the cybersecurity of an organization works at these two levels, both the hardware and the software level, and so all of these will have to be made secure ultimately. That is, the hardware or the device drivers or the operating system or the applications, all of this will have to be secured. So here's a simpler analogy for describing the skills that and techniques that we are going to pick up in the duration of this course. So let's assume there's a person who's very good, physically fit, and who's got combat skills. Now by combat skills I mean martial arts, kung fu or karate, and Kalaripayattu and so on, and how to use firearms, for example how to use an assault rifle or an automatic pistol and so on. So what kind of job or what kind of maybe career can such a person with this kind of physical fitness and combat skills do? Again, physical fitness, this person is able to climb walls, run a 10-kilometer marathon without breaking into a sweat, climb up buildings and so on, parkour kind of thing, right? So that person could then become a police officer or a soldier, or get into the secret services like RAW and IB in India, for example. So the idea is that any of these jobs here is built on the foundation of these two things here, that is physical fitness and combat skills. So it's obvious that a police officer would be physically fit and have very good combat skills, and that also applies for soldiers and secret service agents. Now based on the example which we have seen previously, now coming to the context of cyber security, what we have to understand is that this, the focus of this course obviously. So starting with the basic foundational skill set, which is that of penetration testing, we can think of moving on to a career that's on ethical hacking, or a career that's based on red team engineering, or a career that's based on offensive security, or you could also do a job as a penetration tester, or there is also research in cybersecurity, so you can move on to become a cybersecurity researcher down the line. But the point to note is that this course that we have just started here is like a common course that covers all these skills here that you see in this diagram. Now, one thing I would like to clarify with this diagram is that ethical hacking, red team engineer, or offensive security, or cyber security research, these are not completely disconnected job specs or skill sets. I am actually trying to say that they are heavily overlapping with each other. They actually heavily overlap with each other, which is to say that an ethical hacker does a lot of activities that are overlapping with that of a red team engineer, and similarly a red team engineer does a lot of things that are overlapping with an offensive security expert, and so on. Now, the very motive of this diagram, the very target of this diagram is to explain that penetration testing is the foundational skill on which ethical hacking and red team engineering and offensive security and cyber security expert are based. That's all. That's the only point. So let's try to start with a understanding of what is penetration testing. Now, take for example any system. Now by system I mean it could be a mobile app, or a website, or a web application, or an IoT device or something. So take any of these. So the idea of penetration testing is that given this system, you try to look at it from a security perspective. You try to understand how it works. You try to understand what are the nitty-gritties of the system, especially from the security perspective. That's the whole idea. So you conduct a series of tests, you kind of probe it, and then you try to evaluate what kind of functionalities it has, and how to possibly look at any weaknesses, look for any weaknesses, and so on. So let me repeat that. So the whole focus of the the penetration test is to purely evaluate how good the security of a system is, how strong it is, and if there are any chinks in the armor of the system, and so on. So the focus is purely on security and related aspects. We don't care if, for example, maybe the OTP functionality is not working properly, or there's some text box in which when you type the font is wrong, and so on. That's unrelated stuff. So the whole point is to evaluate the security aspect of the system. That's it. Now, there are three techniques for penetration testing, of which we have manual, which is the most time consuming because it takes a lot of thought, planning, analysis, and so on. But there's also the other two kinds of techniques, which are partially automated and fully automated penetration testing. Of course, with very minimal or zero human intervention. Now, overall, we'll explore these techniques in detail during this course. But overall, the philosophy of penetration testing is to know your target. Now, what that means is, it's like one of those Chinese sayings or whatever. So, the idea is to know your enemies, to know your target, because down the line, when you get a grip of how things work as far as your target is concerned, then you can do a lot of things. You can break into it, you can take control of it, you can make it do things at your whim and fancy. That's the whole idea. So there are three different levels of penetration testing. We have black box, gray box, and white box. So let's try to understand what these are. So black box penetration testing is in fact the most toughest of these, because you just have a bare minimum of information at hand, and the organization that you work for might assign you a target, or you get a target assigned to you, and well, all you get is a one liner, and that's it. And so you are told to investigate and analyze and come back with some kind of a detailed report or something, and that's about it. So that's what makes it the toughest of all three types of penetration testing. So gray box penetration testing is a little bit more easier compared to black box, because you get some kind of minimum amount of information about your target. So for example, the IP addresses on which the target is hosted, maybe it's hosted on the cloud, so you get the domain name and which cloud it is hosted on, the set of IP addresses on which it is hosted, what web server it is running. Maybe it's running the Nginx web server, maybe the server side programming is in PHP, or the the database is MySQL and so on. You are given a set of one or more login credentials which you can use to log in and then go inside, and then again check for any number of vulnerabilities. And white box testing is the other extreme of it's the complete opposite of the black box. So you have the maximum possible information that is given to you about the target. You will also be given one or more set of login credentials, which includes most possibly even admin access. So you have a normal user access and admin level access as well, because you want to test extensively. Of course, you may also be given access to the source code of the entire application, which means you have a very good view of how things work internally, and so you can tailor your penetration tests accordingly and make your penetration test more effective. So at the end of a successful penetration test, you have assessed your target's security thoroughly, and you are also able to understand its vulnerabilities and naturally find ways to exploit these vulnerabilities. Why would you want to do that? Because you want to hack your targets, you want to break into these things, and then extract all kind of information from them, explore what other things you can reach from there, because you can use this target as a potential launchpad for other activities and so on. One more important thing here that I would like to tell you is that there's this bunch of other skills which, if you are able to pick up or you already know and you can sharpen them, that kind of puts an icing on the cake, right? It takes your your career options, your skill sets to the next level. I mean, we have already seen this in the previous diagram, right? So you have this foundational skill set of penetration testing, but once you have these other skills that we are going to look at now here in this list, that kind of takes your opens up a lot more possibilities in this diagram that we have seen. That is, you can get into ethical hacking, you can get into red team engineering, you can become an offensive security expert, or even a cyber security researcher. So the first of these skills that we will try to understand here is reverse engineering. So what exactly is reverse engineering? It's the case where you don't have the access, I mean, you don't have the source code nor the means to access the source code of a software or a program, and yet you just have the executable of that software. For example, if it is Windows operating system, then you just have the exe file of the software. If it is, for example, Android, then you might have just the APK file, and similarly if it is, say, the Mac operating system, then you have the DMG file, and so on. So starting from this executable, you use different tools and different techniques to essentially either understand the way the software is the written, or you're able to somehow generate the source code and then start studying it. So ultimately it's a very good way of trying to understand how a program works in the end. The second skill here is source code analysis, which clearly means that you are able to understand the source code, the instructions, the programming instructions that have been written by somebody else, or sometimes it's your own code. So clearly, the more programming languages you know, in this case, the better. Say Java or C Sharp, PHP, Python, and so on. So the whole point is that when you look at and study and review the code that's written by somebody else, clearly you are able to understand how that person thought, what was the thought process, and you also look at the way things are implemented, and because you gain insights into the way things are implemented as a hacker or as a penetration tester, I mean, that would give you a great amount of leverage, which you would naturally exploit further down the line. Okay. The other critical skills here are observation and creativity, of course, and programming skill. So the overall idea is that the whole process of hacking, of thinking like a red team engineer or a security expert, is a very creative process, right? So I usually quote this example, when I try to explain this to students. You're a crime scene investigator, right? And you come across a crime scene. For example, there's a dead body lying there, and you have some damaged furniture lying around here. There's a phone wire that's been cut, and there's an unknown liquid that's spilled on the floor, and so on. Now, as an investigator, when you look at this crime scene, you try to visualize, you try to piece together what exactly was a sequence of events that has happened here. That's the idea. You see, that requires a lot of insight, a lot of experience, a lot of creative thinking, and hunches and so on. You get the idea. So something similar is required when you want to become a hacker or a red team engineer or a penetration tester in general. So and I would like to clearly state here that this kind of skill doesn't just, I mean, you aren't born with it. The moment you come into this world, you have all this knowledge in your head. No, of course that's not the case. It takes a lot of time, so many years of experience, of hard work, of sweat, and effort, and only then you get to this kind of level. So there's no shortcut to this. There's absolutely no shortcut to this.